Hello everyone, I'm Xianan. Today, I will present our work peer-to-peer localization for single antenna devices. This is a joint work with my colleagues Wei, Xuedou, Han, Tao from Huazhong University of Science and Technology, and Xinyu from UCSD. First, let me introduce peer-to-peer localization. One device transmits wireless signal. The other device determines its position by receiving several packets with no assistance from pre-deployed infrastructures. Such peer-to-peer localization is highly desired in many practical and critical use cases. For example, it can alert parents when their kids go out of sight in a shopping mall. In smart home applications, it can turn on the TV when someone sits on the TV code. Many researchers have proposed solutions for this task. Unfortunately, however, existing solutions have some major drawbacks. The first type of solution is based on the fingerprint. Such systems only navigate in pre-sampled paths and are not robust to environmental variations. An alternative type of solution is based on triangulation or trilateration. However, they all require multi-antennas in both the transceiver. First, the trilateration-based systems like ToneTrack and Cronus require channel hopping to emulate a large channel bandwidth, which imposes constraints on ongoing data communication. None of those systems can be applied to single antenna devices. So, here is the question. How can we enable peer-to-peer localization for single antenna devices without requiring fingerprints? In our paper, we propose P2P locate that enables peer-to-peer localization for single antenna devices. P2P locate uses an on-body backscatter tag to create multipath variations intentionally. Then, it covers the created multipath with user movements to localize the target. The key insight underlying P2P locate is that the tag to target and the receiver to target paths can be used to estimate the direction of the target. In particular, suppose the receiver and one co-located backscatter tag move in a line. The backscatter tag may retrace the locations of the receiver. Once the tag arrives at a location traveled by the receiver, the distance between the target and the tag would be equal to the distance between the target and the receiver at that moment. Based on this observation, P2P locate estimates the moving speed of the target relative to the receiver. Thus, by estimating and comparing with reduced speed offered by the Doppler effect, P2P locate identifies the direction of the target relative to the receiver. Based on this key insight, we designed three components to realize decimeter-level accuracy peer-to-peer localization system, including backscatter CSI separation, parameter estimation, and the localization framework. Please read our paper for more details. We prototype P2P locate based on commercial off-the-shelf devices, including Google Nexus 6P, Intel Wi-Fi card, and the Raspberry Pi. The backscatter tag is customized using ADG 902 and StepMax 10 FPGA. The finger illustrates the floor plan of the environment, while experiments are conducted in space with lab, meeting room, hallway, and corridor. The experimental results showing these two fingers demonstrate P2P locate and achieve decimeter-level accuracy with both static and mobile targets. In conclusion, in this talk, we introduce a decimeter-level accuracy peer-to-peer localization system for single antenna devices. We also propose a novel algorithm to estimate direction information from single antenna devices. We implement the P2P locator system, and the evaluation confirms the robustness of P2P locate in real environments. Thanks for listening.